In weighted moving average, you can give more weight to recent events, but you are limited to the last m observations. Exponential smoothing improves on weighted moving average by taking all previous observations into account while still favoring the most recent observations. In simple exponential smoothing, the forecasted value at time I plus 1 is based on the value and forecasted value at time I and indirectly on all the previous time values. This is the exponential smoothing calculation. D is equal to most recent period value. Alpha is equal to the smoothing factor represented in decimal form. F is equal to the most recent period's forecast, the output of the smoothing calculation from the previous period. In this example, exponential smoothing is used to forecast the monthly sales. Monthly sales values are in column C. A period is assigned to each month. For the first forecast, enter the value from the first sales value equal to C2. Use this formula to calculate the exponential smoothing for period 2. It is based on the previous period's forecast value and the previous period sales value. So each subsequent exponential smoothing calculation inherits the output of the previous exponential smoothing calculation. That's how each previous period's value is represented in the most recent period's calculation, even though that calculation does not directly reference those previous periods. Copy the formula down. Forecast values for other periods is calculated. Create a chart to see visual representation of the exponential smoothing. Select the data that you want to include in the chart. For example, select date, sales, and forecast. On the Insert tab in the Charts group, click on the Insert Line icon and choose the first chart type 2D line. You can see how the exponentially smoothed forecast smoothed the data but still follows the upward trend. Excel has an inbuilt tool to calculate the exponential smoothing. It's called the Data Analysis Tool Pack. The Analysis Tool Pack is an Excel add-in program that provides data analysis tools for financial, statistical, and engineering data analysis. To load the Analysis Tool Pack, click on the File tab, click on Options. Under Add-ins, select Analysis Tool Pack and click on the Go button. Check Analysis Tool Pack and click on OK. Data Analysis Tool Pack is now enabled. It appears in the Data tab in the Analysis group. Let us use this tool to calculate exponential smoothing on the same data we used earlier. On the Data tab in the Analysis group, click on Data Analysis. Select Exponential Smoothing and click on OK. Exponential Smoothing dialog box opens. Click in the Input Range text box. You can enter the input range or click on the Collapse dialog button and select the input range. Click on Expand dialog. In the earlier example, we used smoothing factor alpha 0.25, damping factor equal to 1 minus alpha equal to 0.75. If the input range you selected includes the labels, check labels. In Output Range box, select the cell where you want to see the result. Select Chart Output box for displaying the values in the chart and then click on OK. The results are inserted in column D and a chart is displayed. Alpha is set to 0.25. The previous data point is given a relatively small weight 0.25, while the previous smoothed value is given a large weight 0.75. As a result, fluctuations are smoothed out. Excel cannot calculate the smoothed value for the first data point because there is no previous data point. The smoothed value for the second data point equals the previous data point. To compare the values with different alpha values, repeat the steps for alpha 0.1, 0.2, and 0.8. For alpha equal to 0.1, set the damping factor as 0.9. Select output cell. Uncheck chart to display only values. Click on OK. Repeat the steps. For alpha equal to 0.2, set the damping factor as 0.8. For alpha equal to 0.8, set the damping factor as 0.2. Create a chart to visually compare the results. Select the values. On the Insert tab in the Charts group, click on the Insert Line icon and choose the first chart type, 2D line. When the alpha value is smaller, the damping factor is higher. More fluctuations are smoothed out. When the alpha value is higher, the damping factor is smaller. Smoothed values are closer to the actual data points. To download practice Excel file, please click on the link in the description. If you like this video, please subscribe to our channel.